Hello, today we are going to find the eigenvalues and eigenvectors of the following matrix. To find the eigenvalues and eigenvectors of a matrix, what we have to do is to first find the characteristic equation from which we will devise the eigenvalues. So we make use of this equation whereby we'll say if this is a matrix A, we'll say matrix A minus lambda times the identity matrix. The identity matrix for a 3 by 3 matrix will be having diagonals of 1 1 1 1. Okay, so saying here 1 3 1 1 3 1. Okay, so I'll be making use of these signs on finding my determinant of a 3 by 3 matrix, and I'm going to take the row number 3. Okay, so the minus of this first element of the matrix is 1 3 5 minus lambda and 1. Then the next one, we're talking of this negative 1. The minus of this matrix, we are deleting row, and the column is 1 minus lambda 3 1 and 1. The last element is 1 minus lambda. Its minus are 1 minus lambda 1 1 5 minus lambda. Okay, now finding the factor for each matrix, I'm saying 1 times 1 minus 3 5 minus lambda. Then the second factor is 1 minus lambda minus 3. Then we are saying plus 1 minus lambda. Yeah. So we are saying 1 minus lambda multiplying 5 minus lambda minus 1 u. Yeah, well placed. Okay. So simplifying each and every factor of this expression, you can say 3 1 minus 15 here plus 3 lambda. This will get me to 3 minus 14 plus 3 lambda, which will also give me, if you say 3 times 14 here 2 1, this is going to give me 42 here, negative 42 plus 9 lambda. Getting on to the second factor, we are saying 1 minus lambda minus 3. This is getting me to 1 minus 2 minus lambda, which will get me to 2 plus lambda. Then the last one, this is the first, second. For the last factor, we are saying 1 minus lambda. I'll simplify this to give me 5 minus lambda minus 5 lambda plus lambda squared minus 1. This is leading me to 1 minus lambda. Here I will get a 4 minus 6 lambda plus lambda squared. Okay, now simplifying with the brackets, this bracket which is outside, I'm saying this is giving me 4 minus 6 lambda plus lambda squared minus 4 lambda plus 6 lambda squared minus lambda cubed. Right? If I am to simplify further this, I'm going to get 4 minus 10 lambda plus 7 lambda squared minus lambda cubed, like this. Okay, so I'm going to take each and every factor and then add them together to give me my characteristic equation. Okay, so here we're saying minus 42 plus 9 lambda plus 2 plus lambda plus 4 minus 10 lambda plus 7 lambda squared minus lambda cubed is equal to 0. This is going to give us our characteristic equation. Okay, so we are saying 9 plus this lambda is giving me 10 lambda minus 10 lambda will get a 0. And then we also now say 2 plus 4 is a 6, and then we say 6 minus 42 is giving me minus 36. Then we are now saying minus 36 plus 7 lambda squared minus lambda cubed is equal to 0. Then expressing this a characteristic equation as a positive of this highest power of lambda, we are getting minus 7 lambda squared plus 36 equal to 0. This is my characteristic equation from which I'm going to get the eigenvalues. Okay, when working this characteristic equation, what we have to do is to find the factors that if we put inside this bracket we will get a 0. So we'll try out the factors by taking note of the coefficients of 36 and the coefficient of lambda cubed. Okay, so I will start by trying minus 2 inside the equation. Minus 2 cubed, 7 minus 2 plus 36. Here I'm getting negative 8. Then there I'm getting, this is a squared, I'm getting a negative 28 plus 36. This is giving me a 0. So it means that lambda plus 2 is equal to 0 is a factor for this characteristic equation. So then I will now divide dividing the characteristic equation by lambda plus 2 so that we can get other factors of this characteristic equation. Okay, lambda into lambda cubed, that's lambda squared. Then if you say lambda squared times lambda, that's lambda cubed. Then here we will get plus 2 lambda squared. Then we subtract, here we get a 0. Minus 7 minus 2 lambda squared, that's minus 9 lambda squared. Here we get minus 9 lambda. Here we have a 0. and we are getting minus 9 lambda squared minus 18 lambda. Then we found a 0 here. 0 minus minus 18, we get 18 lambda. Now here we are getting plus 18, then multiplying there, we are getting 18 lambda plus 36. Okay, we subtract, this will give us a 0. So we are saying lambda plus 2 lambda squared minus 9 lambda plus 18 is equal to 0. We factorize this so that we can find. So factors for minus 9 lambda squared minus 9 lambda plus 18, we are seeing that it's lambda minus 3 and lambda minus 6 equal to 0. So the eigenvalues are lambda is equal to minus 2, lambda is equal to 3, and lambda is equal to 6. These are the eigenvalues of this matrix A.